Yeah, thanks for joining this Tech Week talk about how we built the trivago weekend frontend with Next.js and a couple of other exciting technologies. Oops. So if we haven't met yet, my name is Malte. I'm doing JavaScript since 8048, joined trivago in 2016. Started building features for our core product in different teams, then moved to the platform team, which is building and maintaining our front-end architecture. And I finally joined the Weekend Web team last year, where we are building the trivago Weekend website. So what is trivago Weekend? Beginning of 2020, I was asked to move to this new team that was supposed to build a whole new trivago product that would focus on like regional getaways. Unlike our core product, which mainly focuses on comparing hotels and deals, Weekend aims to inspire users in terms of what interesting destinations are close by, what interesting sites are around, and what activities are available there. So the product was kind of like our response to the travel restrictions caused by the corona pandemic. You can check it out on weekend.trivago.co.uk. We are live for most platforms, but the main focus is currently the US and the UK market, where we also have the most features and content available. So when we planned Weekend, our product managers were quite open to whatever technologies we wanted to use. We just had a few requirements that were obviously ship it fast. They said, okay, ideally in 3 months we would have a first prototype that would show that we could show to our stakeholders, and we also wanted to have a modern look and feel with a like snappy user interface. And since the team would hire new developers and the product would grow, we needed to ensure that we could easily onboard them. Also, when you start a new product, you might change the direction a little bit, the layout, the data from week to week. And so we had to ensure that the code base was flexible enough to do so. We also had to support a couple of like trivago specific software, like our A/B testing framework and our GraphQL infrastructure. Lucky enough, some months ago, some colleagues of mine and I, we were experimenting with a whole bunch of like modern front-end technologies that we were excited about. And at that time, the trivago front-end was quite a few years old. Like it was still running on a PHP-based server. We had a front-end that was built with our in-house framework with a lot of legacy code. And it really wasn't fun working with it. So as a side project, we started rebuilding the trivago frontend from scratch with all of these technologies that you can see here. And we experimented a bit with different ways of how we organize the code, how we build components, and what's the best way to integrate TypeScript, and so on. And as a result, we had this little app that quite looked like trivago and had the main features implemented. Of course, not all details, because even though trivago seems like a quite simple app, it's insanely complex. So when our product manager approached us, we were like, yeah, we got something for you that we could base the weekend frontend on. And so from that prototype that we created, we ripped out like everything that we didn't need and started building the weekend frontend on top of it. And as a base, we obviously took Next.js, which is probably the most popular and mature React framework. You set it up with like no config. You have all you need in terms of compilation and bundling. You get support for TypeScript, for CSS modules, which we have been using already at trivago. You get proper routing, code splitting, server-side rendering, basically everything you could ask for as a front-end developer. And since in the past, we were struggling with growing bundle sizes, and even though Next.js does a quite good job at minimizing what is shipped to the browser, we still try to keep the bundles as slim as possible. And therefore, we decided to go with preact, which is a kind of like drop-in replacement for React, and the whole library is just 3 KB in size, and most of the time it's even faster than React. We also found a Next.js demo from Jason Miller, who's one of the creators of preact, where he replaced React with preact. And he published that in this repository that you can see here. And if you also plan to do that, check out this repository. Yeah, we basically stole everything from this whole setup, and it's working flawlessly. You can use preact exactly as if you would be using React, and you can even integrate the preact dev tools, and it's, yeah, so far really working well. That's also the reason why trivago is sponsoring preact. We have a couple of other open source projects like Webpack that we are sponsoring, but I'm pretty excited about this one because I think it's still an underrated project. So GraphQL. GraphQL and the Apollo platform are already part of the trivago infrastructure, and I think it's been now 2 or 3 years since we completely switched to a central GraphQL server at trivago. And before that, we have been using different REST endpoints, some of which were even still part of our legacy PHP setup. So yeah, nowadays, the GraphQL server is basically the data hub for all our front end. And it's super easy to integrate with React and TypeScript, and it really gives you a nice developer experience. So that being said, we are using a strict TypeScript config, which enables some great tooling and some outstanding IDE support. And since we might come across refactorings because the requirements change, or we just want to clean up and improve our code, TypeScript really helps us refactoring our code and spotting errors early. And yeah, it overall improved our productivity and the developer experience. Since you might not have seen trivago Weekend, let me show you some screens to give you a better idea of what we are talking about. So this is the desktop version that you will see when you land on trivago in the UK market. And as you can see here, we have a similar structure like trivago. You got the search form on top and a couple of results below. Yeah, you can see a whole lot of cards and sliders and grids. Some events that are happening around you. You can refine your search here with these filters. You can click on those cards to get more information about a certain event or POI. Some will lead to a detailed page, some open more information in an overlay. And here at the bottom, you can see the typical accommodation items that you probably know from the trivago website. We also support different viewports like tablet and smartphone, and we optimized those for smaller screens, obviously, but also for touch functionality. As you can see here on the right, the search form. If you click on a mobile form on that search form, you will enter a full screen search form that is then optimized for touch devices. You can also see a slight difference in the layout. Here we are using grids to display some information. Here there's another layout with sliders, so it's easier for smartphone users to swipe through these points of interest. And yeah, we got quite some complex components here and there, like the desktop calendar. We, as I said, have the search form for mobile with a whole different implementation of the calendar, a map showing up where you are or where you put your destination. We have a gallery for our accommodations that you can find on Weekend, and we support different viewports also there and even different orientations. We have some detailed pages like this one here for events, or a destination detail page. And the point why I'm showing you this is because even though it seems like a quite simple app, it's fairly complex. And oh, someone ring the bell. Which brings us to code organization, which is not the sexiest problem to solve, but for sure one of the most important aspects when you want to build a maintainable code base. So when you start with a brand new Next.js based app, you will have something like this here on the right. You have a couple of files here and there, a pages folder that contains the entry points and components that are shown on your pages. And yeah, we were just in front of the problem, how can we fit all this complexity, these features, this logic within this folder so we can so we still have a maintainable code base. And we already had something like a mono repo structure in other front-end projects, where you have like packages that cluster certain logic or components, but nothing that really shined when the code base was growing. So we wanted to have these NPM style modules, but with a better categorization. And that brought us to namespaced modules like the search form module here that lives within the features namespace. And then we were asking ourselves, what kind of modules do we even have and which namespaces do we need? So as I said, pages are the entry points in Next.js. They define your routes and which components will be rendered on your page. And yeah, pages is not really a namespace here. I just put it here to make this top-down relationship a bit more clear. So the first namespace that we have is the app namespace, which contains, let's say, different micro front ends. And basically every page has one single micro front end that is imported from the app namespace, like in this example below. So here you have the destination page basically, or destination micro front end, and your page is basically just rendering this simple component, and everything else is handled by this particular component itself. And these apps are then composed of features and experiments. As an example for such a feature is the search form. All components, hooks, functions, types that are somehow related to the search form are clustered into this particular module. So every app that needs a search form can just import it from this module and use it. In this way, it's quite easy to find a specific component or hook if you know it somehow has to deal with the search form. And on the other hand, if you create a new component or file, logic, whatever, it's easy to find a place where to put it. The experiments namespace works just like the features namespace. The difference is that those modules are still part of an A/B test. For example, if we want to test a new POI or accommodation card, we put it into the experiments namespace. And once the test is accepted, we move it to the features namespace. Or in case a feature is rejected, we simply delete the whole module and remove all usages, and you're done. The last namespace is the packages namespace. And here we put all components, hooks, function types, whatsoever, that are not specific to the trivago Weekend app. For example, we have an array module that implements some array helper functions, or we have our components module that implements certain design system related components. And as a rule of thumb, anything that you could publish publicly to NPM, we would put it into this namespace. Yeah, and this is how our source folder looks like. You can see all the mentioned namespaces, the pages directory, and a directory for global styles. So let's have a look how all these namespace modules finally look when you are coding. For example, here I'm trying to use a certain component. The IDE already has some suggestions. It completes my the name of the component in this case, and you can see it automatically adds the right imports there, and you can even navigate through your code super easily. And in order to achieve this IDE support, we had to create a little script that looks for package JSON files and automatically adds the information that it finds there to the path mappings of the tsconfig files. There are different ways to achieve this IDE support, but we found that path mappings actually work the best for most IDEs and tools like Jest or Cypress. All right, then let's have a look into our features directory or features namespace, where you can see the anatomy of such a module. Every module basically just looks like a package that you would install from npm. You have a package JSON file, you have a README file, a source folder with all your components, hooks, functions, types, whatsoever, and the index file basically then defines the outside API for your module. So creating such a module or package can be quite cumbersome. You need to create this new directory, you need to add source folder, index files, and all the stuff that I just mentioned. And that's why we implemented a couple of generators that help us easily create new modules or components or hooks. And we did that with hygiene.io. Check it out if you have similar problems. It's really easy to integrate. And as you can see here, it's really making your life easier. We can choose now a namespace where we create a new package or micro frontend in this case. You can even add a title for the README and some more description. And Hygen then automatically generates all the files, the package JSON, the README file, and the source folder with your index file. And the next step would be, for example, to create a new component. And we also have a command for this. It basically works the same. You put in your command, you get asked to which namespace and module you want to add this component, in this case, app accommodation. You give it a name, and the generator will generate all the needed files. Here you can see it's exporting it automatically from the index file. Oops. It's creating the props and naming everything, and even the CSS module file. So that really helps with speeding up your development cycle. So the next thing I want to show you is the scaffold of the Weekend app. And by that, I mean the custom app file that you might know from Next.js projects. For those who don't know how this app component works, it's basically the root component of your app that doesn't get unmounted when you are navigating between pages. And that's also the place where you put all of your global providers and global logic. And in our case, here you can see the catch errors components is the first one. It obviously catches errors that bubble up the component tree. We have our Apollo provider that enables the components down the tree to access the Apollo client for our data management. We have some configuration, localization going on, A/B test, event bus, logging, marketing, cookie notification, and finally the page component that you want to render. And the props that you see here in the application component are coming from the infamous get initial props function, and that function is, as you might know, responsible for fetching or generating data that your application needs. Like the translations, like some config props, and everything that needs to be, every data that your application somehow needs and needs to pass down to providers. And at the end, you can see we are wrapping this application with a higher order component that basically instantiates our Apollo client and passes it through to the application component and then to the Apollo provider. Which brings us to the point of data. As I mentioned before, we have a central GraphQL server that our mobile apps, the trivago website, and our weekend website are talking to. And this server is basically connected to all our backend services and basically composes all the data that we need or that we request within a query and sends it back to us. So how does it look like when we need to fetch some data? This is the use destination hook that we use whenever we need some information about a certain destination, like the translated name or maybe the coordinates whatsoever. And when working with the Apollo React integration, most of the time you will be using the use query hook that you get from Apollo, from the Apollo React integration. And what we are doing here is we are importing a query file where you define basically which fields do you need from your server. You pass that query to the use query hook along with some input variables that will then be injected into that query. And we are also passing some type definitions here, which basically tell TypeScript that this data is of a certain type, and the same is goes for the variables. So we have basically type safety when the data comes out, comes back from the server, and when you send it to the server. And these types are automatically created based on the queries that we define in our query files here. And yeah, this is how such a query file looks like. If you have used GraphQL before, you probably know this. And yeah, here we are defining the query for the destination. And due to the Apollo VS Code plugin, we get some great IDE support, as you can see here, with code navigation or auto completion, and even information about how long a certain field takes to resolve. And since we are passing those types to the use query hook, we get instant TypeScript support, as you can see here, when we are entering the data that we are getting back from the server. So it's basically from end to end, it's type safe, and your IDE can always tell you if you're working with the correct data or not. All right. Oh yeah. Yeah. In order to get this kind of integration for GraphQL, you obviously need an account for the Apollo platform. You need to implement your GraphQL server with the Apollo server package, and on the client you have this Apollo client package, which also ships with the code generator that is responsible for creating your TypeScript type definitions based on your queries. And finally, the VS Code integration, and there's probably also one for WebStorm or whatever IDE you are using. So yeah, let's check how we localize the Weekend app. So when we started building the front end, Next.js didn't have any support for localization and translations and so on. They nowadays have it. I guess they added it in the last version or so. But yeah, we had to build our own system for that, which basically consists of extracting the snippets that we are using throughout our app, fetching the translations for those snippets, and then finally serving the translation files to the front end. I'm not going to go into detail how the routes work, because Next.js nowadays has probably a better solution than we have for this. So yeah, here you can see how we are using the use translations hook. We basically just pass it one or more snippets, and for every snippet that you pass there, you get a function back. And once you want to render your translation, you call this function. You can even pass some data for your placeholder, and then it renders the snippet in the desired language with the desired data. And so in order to automatically collect all the snippets that we are using throughout our app, we had to build a couple of plugins into our build system. So on top, you see this file that I just showed you. It first gets processed by a Babel plugin that adds some more information about which snippets are used in this file. And then Webpack picks this information up and calls our translation service to get the translations for all languages and all snippets. And from this information, Webpack creates finally our translation files. And yeah, based on which language the user selected, the respective language file will be loaded by the get initial props functions that you've seen earlier. And this localization configuration is then passed to our localization provider, which in turn makes those translations available to the use translations hook, and then can render your translated snippets. And this is how it looks like in action. Here we are changing the language from English to Spanish and vice versa, and it does that without even reloading the page. So whenever we change the language, we have a call to get initial props, which then gives us the new translations for the selected language. Yeah, but there's more to localization than just translating strings. We also need to format dates, numbers, and prices. And for that, we are using the Intel API. Here you can see how our useDateTime formatter hook works. We are basically grabbing the language that the user selected, and then we are creating, based on that, a new instance of the datetime format object, and we use this formatter object then to format the date that you are passing to us. And this is how it looks like when you are using it in a component. You call the hook, you get this format function, pass it a date, and then this function takes care of giving you back the right string. All right, UI architecture. This is basically an example of how a usual component looks like in our code base. This is the chips components. We use these little chips in our POI cards. You can see it here on the bottom. And as mentioned before, we are using CSS modules. We have type definitions for our component props and then some basic markup. So nothing fancy about it. But we have a couple of rules that I want to show you that help us ensure that our components are reusable and robust. So the first one is that every component has its own folder with a component file, a CSS module, and an index file for, let's say, prettier imports. Nothing else is allowed to go into this folder, because we have seen people putting component files and CSS modules and hooks just everywhere, and at some point you just have no idea what belongs where and what component is importing another component. So this is one of our first rules: one component, one directory, nothing else in it. Next one is every component should have a single root element. So we try to avoid fragments, because it's pretty easy to break your layout and your styles when you dump a bunch of elements next to another bunch of elements. Like there could be side effects, and you could just wrap it within a list, a container element whatsoever, and you get full control of how your child elements are rendered. Also, components must not expose a class name property, because the problem is if you're using this component and you haven't implemented it yourself, you don't know what styles are going on, what styles are defined in this component, and all the children that the root element could have. And so it's quite easy to break your component styles from the outside if you now add a class name that sets the container to display flex, let's say. And yeah, then everything just goes nuts in there. We also try, or root elements in our components are supposed to not have spacings defined to the outside, because that makes them less reusable. I've seen components that accept the props for like where to show the margin on the left, on the right, which size, and that in the end just leads to more problems than it solves. So what we are doing is, if we want to define spacing to the outside, we just wrap that component within another element and then define the spacing there. And yeah, all those rules we use to ensure that our components are reusable and stay robust. So another topic is loading states. We actually don't have separate components for our loading states, because it's quite hard to maintain two separate components. We tried that a couple of times and it's not really working well. So you can easily run into flickering issues or an outdated UI whatsoever. So these two screenshots are like the same component. The only difference is that we don't pass any data. You can see the POI is nullable. The difference here is that we don't pass any data to this component, which signals that it should show a loading state. And what we usually do is we are adding an isLoading class to the root element, let's say, and then we define styles for certain elements that should show a gray line, for example. As you can see here on the right, there's this title element, and when we are in loading state, we don't have any text here in that element. That's why we are using this sass mix-in that ensures that this element stays at the same height as if it would have text, and also like has this rounded corners and the gray color. And yeah, this is we also passing the isLoading state to other components, then in turn also switch to a loading state. This is how it then looks like on our website. You have no flickering, no layout shift, and it's pretty smooth, as you can see here. So to come to an end, I just want to show you a couple of more components that we built and that I really liked. The first one is the card carousel. As you can see here, it's used within different type of cards. We are using them for events, for accommodations, for POI, and it supports different viewports. It has a really nice UI, feels super smooth on mobile. And as you can see here in the code, it has a pretty simple API. You can basically just throw a couple of card components to it, and it will take care of aligning them correctly for different viewports, for enabling swiping and navigation. You can even use a certain hook to programmatically tell this carousel where to scroll. This is, and also for logging, it gives you some hooks, and we are using it quite a lot. I mean, it seems quite simple, but it's for sure one of the most complex components that we have. Another nice component is the mobile calendar. So when we first built this calendar, we had quite some issues with rendering performance, even on current iPhone devices. And the reason is that when we are opening this calendar, we have to instantiate around like 1,000 components, because we show the days for a whole year, and they are like wrapped by multiple components and so on. So we get to this high number of components. So what we are doing here is we just try to render as less components as possible on the first rendering in order to show the first parts immediately after the user clicked to open the calendar. So we basically know which dates are selected and which months probably will not be visible when mounting this component. And for those months, we just wait another render round before we are finally rendering the days. You can see how we do it here in this code example. We just have here this use effect that runs after the component has mounted, and then we set render days to true, and then the remaining days will be rendered. And that improved the startup time for this calendar like drastically, like you can see here in the video. I know it's a quite stupid approach, but it really works well. Yeah, the last one is the slider panel. I like this one because when you're using it on your mobile phone, it feels pretty smooth, just as a native app would feel like. And you can also, as you can see here in the video, mount it everywhere. We are using it as like overlay panel on mobile, or for some tooltip, let's say, layout within these accommodation cards. Yeah, the implementation was also quite easy. We are just adding and removing class names. We don't have any fancy animation library. And yeah, I really like that one.